There's one promise that every government on Earth has made to its citizens for the last 200 years. Work hard, learn a skill, and there will be a job waiting for you. That promise survived the steam engine. It survived the assembly line. It survived computers, the internet, and globalization sending factories overseas. Every single time a machine threatened to take a job, new jobs eventually appeared to replace it. That was the deal. Technology destroys some jobs, but it always creates more than it takes. Economists have a name for this. They call it the lump of labor fallacy. The idea that there is only a fixed amount of work in the world, and that machines doing some of it means humans simply have less. For 2 centuries, that fallacy lived up to its name. It really was a fallacy. The jobs always came back, often better than before. So when reports started surfacing out of China describing factory floors where rows of robots run entire production lines for 20 hours a day with almost no human supervision, the first reaction from most economists was the same one they have given every time this question comes up. Do not worry, new jobs will appear. But the people actually walking through these factories, the engineers building the robots and the workers watching their own roles disappear in real time, are telling a very different story. And the numbers now coming out of China are big enough that even economists who have spent their careers defending that old promise are starting to ask whether this time might actually be different. If you find stories like this fascinating, the kind of shift that is quietly reshaping how the entire world works, hit subscribe so you do not miss the next one. A like helps more people find this video, and this is one that affects basically everyone watching it. To understand how we got here, you need to understand what was happening on Chinese factory floors just a decade ago, because the starting point matters enormously. In the 2010s, China's manufacturing advantage was built almost entirely on cheap, abundant human labor. Hundreds of millions of workers, many of them migrants from rural provinces, staffed assembly lines across the country's industrial heartland. Factories in cities like Shenzhen and Dongguan ran on armies of workers doing repetitive tasks for hours at a stretch, assembling electronics, sewing garments, packing goods for export. This was the engine that made China the manufacturing capital of the world. It was not magic. It was scale, discipline, and an enormous available workforce willing to work for wages that undercut almost every other country on Earth. Entire cities grew up around single factory complexes, with dormitories, cafeterias, and informal economies built to support the rhythm of shift work that ran around the clock. But that advantage was already starting to erode by the early 2020s, and not because of robots. Wages were rising as China's economy matured. A generation of younger workers, more educated than their parents, increasingly did not want factory jobs at all. Vietnam, Bangladesh, and other lower-wage countries began pulling away the kind of basic manufacturing work that used to automatically go to China. Chinese manufacturers faced a choice that was becoming impossible to avoid: compete on cheap labor against countries that could now do it more cheaply, or compete on something else entirely. China chose something else entirely, and the bet they made was robotics, deployed at a scale and speed that no other country has attempted. The numbers describing this shift are difficult to fully process. According to data from the International Federation of Robotics, China installed more industrial robots in a single recent year than the rest of the world combined. Not more than any other country, more than every other country on the planet added together. The country now operates well over half of all industrial robots installed worldwide in any given year, a share that keeps climbing. Robot density, the standard measure of how many robots exist per 10,000 manufacturing workers, has risen in China from a modest figure a decade ago to a level that now rivals or exceeds traditionally automation-heavy manufacturing economies like Germany, Japan, and South Korea. But the raw robot count only tells part of the story, and it is the less interesting part. What changed everything was not just more robots. It was what those robots became capable of doing. A decade ago, industrial robots were essentially specialized tools. A robotic arm on a car assembly line could weld a door panel with incredible precision, but it could only do that one task, in that one position on that one part. If you wanted it to do something different, you needed engineers to reprogram it, often taking days. These robots were powerful, but rigid. They were closer to very expensive, very precise machinery than anything resembling flexible labor. What has emerged out of China's manufacturing sector over the past few years is a different category of machine entirely, generally described as adaptive or general-purpose industrial robots. These systems combine computer vision, machine learning, and increasingly dexterous robotic hands to handle tasks that used to require a human's ability to see, judge, and adjust on the fly. A robot on a modern Chinese electronics assembly line does not just repeat one motion. It can identify which of several component variants is in front of it, adjust its grip pressure based on the material it is handling, and flag a defect that does not match its trained visual model, the exact kind of judgment call that used to require a trained human inspector standing at that station. The factory floor where this shift is most visible is not a single facility, but a category, what Chinese industry now calls dark factories, sometimes called lights out manufacturing. The name comes from a simple fact. These facilities do not need lights because there are no human eyes inside them to see by. Production lines run in total darkness, supervised remotely by a small team monitoring dashboards from an office that might be in a different city entirely. One widely reported facility, a smartphone components plant operated by a major Chinese electronics manufacturer, runs production around the clock with a workforce reduced by more than 90% compared to the same line a decade earlier. The handful of remaining employees are not assembling anything. They are maintaining robots, writing the software that controls them, and handling the rare edge cases the machines cannot resolve on their own. Walk through one of these facilities, or watch the footage that occasionally gets released to journalists and industry conferences, and the first thing that strikes you is the silence, not the absence of sound exactly. Robotic arms still hum and click through their cycles, but the absence of the particular noise that has defined factory floors for 2 centuries, the overlapping chatter, footsteps, and constant human motion of hundreds of people working in close proximity. What remains is closer to a server room than a traditional factory. Rows of machines executing precise, repeated motions in an environment built for equipment rather than people. This is the part that should make you pause and actually sit with the number. A facility that once employed hundreds of assembly line workers per shift now employs a few dozen technicians overseeing the entire operation. The work did not get easier. It got eliminated. The jobs that remain are real jobs, often better paid than the assembly line work they replaced, but there are far, far fewer of them, and the skills required to do them are completely different from the skills the displaced workers actually had. Multiply that single facility across an entire manufacturing sector, and you start to understand where a number like 2 million comes from. Industry estimates and labor ministry data tracking. China's electronics, automotive, and textile manufacturing sectors over the past several years point to a cumulative reduction in factory floor positions in the low millions, concentrated heavily in exactly the kind of repetitive assembly and inspection work that adaptive robotics handles best. This was not a single overnight event. It happened in waves, factory by factory, region by region, as each facility hit the point where automation became cheaper and more reliable than the human labor it replaced. But from the perspective of the workers experiencing it, region by region was close enough to overnight. An entire shift of workers would arrive 1 week to find their line reorganized around new equipment, and within a matter of months, most of them would no longer have a position on that floor at all. The economics driving this shift are not complicated once you see the actual numbers involved. A modern adaptive industrial robot now costs a fraction of what equivalent systems cost just 5 years ago, while computing power and battery technology have improved enough that these machines can run reliably for an entire production shift without intervention. A robot does not get tired during a 20-hour shift. It does not need health insurance, overtime pay, or factory dormitory housing. It does not unionize. It does not call in sick. Once the upfront capital cost is paid off, typically within 2 to 3 years for a high-volume facility, the ongoing cost of running a robotic line is dramatically lower than staffing it with human workers, even at China's relatively low manufacturing wages. For a factory owner facing rising labor costs and shrinking profit margins in an intensely competitive export market, that math is not a difficult decision. It is closer to an obligation. Manufacturers who delayed automating found themselves undercut on price by competitors who did not delay, creating a kind of forced momentum across the entire sector. Once enough major manufacturers automated a particular type of production line, the ones who had not were no longer competitive, regardless of whether they wanted to make the switch. What makes this moment different from earlier waves of automation anxiety, the kind that has come and gone since at least the 1980s, is the breadth of what these new robots can actually do. Previous generations of industrial automation were largely confined to heavy, repetitive, physically demanding tasks, exactly the kind of work that was already considered undesirable. Welding, heavy lifting, painting. Few people mourned the loss of those specific jobs because the work itself was punishing. What is being automated now includes tasks that were previously considered safely human territory precisely because they required judgment, dexterity, and visual discrimination. Quality inspection, delicate component assembly, sorting and packaging that requires distinguishing subtle variations between similar items. These were the jobs that survived earlier rounds of automation, specifically because robots could not do them reliably. The new generation of adaptive, vision-equipped robots can. This has triggered a genuinely uncomfortable debate among labor economists, including many who have spent their entire careers confidently repeating the old promise that automation always creates more jobs than it destroys. The traditional argument goes like this. When weaving looms automated textile production in the 19th century, The workers displaced eventually found new roles in factories, then offices, then service industries that did not exist before automation freed up labor and capital to create them. The economy is dynamic. New industries emerge. New skills become valuable. The transition is painful for the specific people displaced, but the broader system adapts and absorbs them, or absorbs their children within a generation or two. The uncomfortable question being raised now is whether that historical pattern depended on something that may no longer hold. Namely, that the new jobs created by each wave of automation required skills that displaced workers, or at least their children, could realistically acquire. Farm workers displaced by mechanization could become factory workers. With a relatively modest amount of retraining, factory workers displaced by earlier automation could become service workers, retail employees, logistics coordinators, again with retraining that, while difficult, was achievable within existing education systems. The jobs being created by this current wave of advanced manufacturing are disproportionately concentrated in robotics, engineering, machine learning, and advanced technical maintenance, fields that require years of specialized education. Most displaced factory workers simply do not have access to, and in many cases, are well past the age where retraining into an entirely new technical career is realistic. A 45-year-old assembly line worker who has spent 2 decades doing precise, repetitive manual tasks is not well positioned to become a robotics maintenance engineer, no matter how motivated they are, without years of education that most displaced workers cannot afford to pursue while also supporting a family. China's government has not ignored this problem, and the response gives some indication of how seriously officials are taking it. Several provincial governments have rolled out large-scale retraining programs specifically targeting workers displaced by automation, covering everything from basic robotics, maintenance certification, to logistics and e-commerce operations roles that have grown rapidly alongside automated manufacturing. Subsidized vocational training programs in manufacturing hub provinces have processed hundreds of thousands of displaced workers over the past several years, with mixed but real results. Surveys of program graduates show roughly half successfully transitioning into adjacent technical or logistics roles within a year, while the remainder either struggle to find comparable work or shift into lower-paying service sector positions. The programs themselves vary considerably in how they are structured. Some, particularly in Guangdong province, where much of the electronics manufacturing automation has concentrated, partner directly with the same companies doing the automating, training displaced assembly workers, specifically for the maintenance and oversight roles that remain on the newly automated lines. This approach has the highest reported success rate, since the training is built around actual open positions rather than general skills with no guaranteed destination. Other provinces, with less concentrated industrial automation and fewer large manufacturers willing to partner on training pipelines, have struggled to match displaced workers with genuinely available roles, leaving graduates with certifications but no clear path to employment that uses them. That 50% success rate is, depending on how you look at it, either an encouraging sign that retraining can work at scale, or a sobering reminder that even with significant government investment, a substantial share of displaced workers end up worse off than before. Both readings are true simultaneously, and that tension is exactly what makes this moment so difficult for policymakers to navigate confidently. The international reaction to what is happening inside China's factories has been a mixture of alarm and aggressive imitation. Manufacturing-heavy economies that compete directly with China, including Vietnam, India, and Mexico, are watching this transition with a particular kind of dread. These countries had positioned themselves as the next destination for manufacturing work that was becoming too expensive for China, banking on exactly the kind of labor cost advantage that automation is now making irrelevant. If a Chinese factory can run with 1/10 of the workforce at a competitive cost, the wage advantage that countries like Vietnam and Bangladesh were counting on to attract manufacturing investment shrinks dramatically. Why move a factory to a country with cheaper human labor when the Chinese alternative barely needs human labor at all? Vietnamese and Indian trade officials have both publicly acknowledged this concern in recent industry forums, with several explicitly stating that their countries' manufacturing growth strategies, built around offering lower wages than China, may need fundamental rethinking if Chinese factories continue reducing their dependence on labor costs altogether. A trade ministry official in Vietnam was quoted at a regional manufacturing summit describing the shift as removing the entire foundation their country's industrial strategy had been built on for the past 15 years. Mexico, which had been benefiting from a wave of manufacturers relocating production closer to North American markets specifically to avoid Chinese labor cost increases, now faces the possibility that the labor cost gap motivating that relocation may simply stop mattering as much. At the same time, manufacturers in the United States, Germany, and Japan are racing to adopt similar adaptive robotics technology, partly to remain competitive with Chinese manufacturing costs, and partly out of a genuine belief that this represents the future of industrial production, regardless of where it happens first. Major American automotive and electronics manufacturers have announced significant increases in robotics investment over the past 2 years, with several executives explicitly citing Chinese manufacturing efficiency gains as the competitive pressure driving the decision. German industrial firms, long considered leaders in traditional industrial automation, have publicly acknowledged that the adaptive, vision-based robotics now standard in Chinese facilities represent a meaningfully different generation of technology than the fixed automation systems that powered earlier German manufacturing dominance. The conversation in boardrooms outside China has shifted from whether to automate at this level to how quickly it can be done without falling permanently behind. There is also a strategic dimension to this that goes beyond simple manufacturing efficiency. A factory that requires very few human workers to operate can, in theory, be located almost anywhere, including locations chosen for reasons that have nothing to do with available labor. Proximity to raw materials, energy costs, shipping infrastructure, or geopolitical considerations all become more important relative to labor costs, when labor is no longer the dominant input. Some analysts studying Chinese industrial policy believe this is a deliberate part of the long-term strategy, building manufacturing capacity that remains competitive even as Chinese wages continue rising toward developed economy levels, locking in China's position as the world's manufacturing base regardless of how labor costs evolve. If the cost of running a factory in China and the cost of running a comparable factory anywhere else both converge toward the cost of robots and electricity rather than the cost of human wages, the traditional argument for relocating manufacturing to chase cheaper labor simply stops applying in the way it always has. None of this means the transition is complete, or that every prediction about its scale will prove accurate. Significant parts of manufacturing remain difficult or uneconomical to automate, particularly highly customized, low-volume production, where the cost of programming and calibrating robots for constantly changing tasks exceeds the cost of simply employing flexible human workers. Industries involving complex assembly of non-standardized products, certain types of garment manufacturing, and small batch specialty production have automated much more slowly than electronics and automotive sectors. And some economists argue these sectors may remain primarily human-staffed for decades, not because robots cannot eventually handle them, but because the economics do not currently justify the investment. There's also real uncertainty about how durable China's current robotics advantage actually is. Robot manufacturing technology is not exclusively Chinese, and competitors in Japan, Germany, and increasingly the United States are investing heavily to close whatever gap currently exists. Some industry analysts argue China's current lead is more about speed and willingness to deploy at scale than about owning fundamentally superior underlying technology, meaning the advantage could narrow significantly within a 5 to 10-year window as other countries catch up on deployment. Whether that catch-up actually happens fast enough to matter is itself a genuinely open question, one that depends as much on political will and capital investment in those countries as it does on the underlying technology itself. What is not really in dispute, even among economists who remain optimistic about the long-term picture, is that the transition happening right now is faster and more disruptive than previous waves of automation, and that the safety net available to workers caught in the middle of it, both in China and in the countries trying to compete with it, has not caught up to the pace of the change. The old promise, that new jobs always come to replace the old ones, may still turn out to be true over a long enough timeline. But for the specific workers walking out of factory floors that no longer need them, watching their stations replaced by machines that do not get tired and do not call in sick, the gap between the jobs disappearing now and whatever jobs eventually replace them is the part of the story that matters most, and it is the part nobody currently has a confident answer for. For 200 years, every time a machine threatened to take human work, the work eventually came back in a different form. The question being tested right now, on factory floors across China and increasingly everywhere manufacturers are racing to keep up, is whether that pattern was a fundamental law of economics, or whether it was simply true for exactly as long as machines could not yet do everything a human could do. Nobody fully knows the answer yet. But for the first time in a long time, the people whose job it is to know are not entirely sure either. If this changed how you think about the future of work, hit the like button and subscribe, so you catch what we cover next. We dig into stories like this every week, the kind of shift that is quietly rewriting the rules nobody thought could change this fast. Here's the question for the comments. If you had to bet, do you think the old promise still holds? That the jobs eventually come back? Or is this time actually different?